This lesson looks at the method of substitution for solving systems of equations. So I'm just going to introduce this topic by starting off with a couple of basic addition facts to show us the concept of substitution. So right now we have two statements with which you would agree. 4 does equal 3 plus 1, and 5 plus 4 equals 9. Well, substitution says that if two things are equal, I can substitute them into another equation and still get the same result. So for instance, 4 equals 3 plus 1. So since these two things are equal right here, instead of this 4, I can put in other words, substitute 3 plus 1 for 4 and still get the same result. Let's see what happens. I'm going to remove that 4, and in its place I'm going to put 3 plus 1. And does that still equal 9? Well, yes. 5 plus 3 is 8, and 8 plus 1 is 9. So that's the idea behind substitution. Let's now look at how it applies to systems of equations. So, let's say you're given these two equations here. Y equals 2x and 4x plus y equals 12. And I want to find the value for x and the value for y that make both of these true. Well, just as in the previous example, I can substitute in for y the value 2x because y is equal to 2x. So what I can do is take this 2x, remove y, and put it in right there in its place. So now what I can do is combine these, since they're like terms, and start to solve for x. So 4x plus 2x equals 6x, and therefore 6x equals 12, and to find x, I divide both sides by 6, and x equals 2. Okay? Now that I found x, I can go take that value and plug it back into either of these equations and find y. Well, I think it might be easiest to go to this first one right here. Plug 2 in for x, and so what I would get would be y equals 2 times 2. So therefore, y equals 4. So our answer is x equals 2 and y equals 4, or if we were writing them in an ordered pair fashion, it would look like this. So let's double check that. If I put in four here for y and 2 for x, does 2 times 2 equal 4? Yes, it does. Now what happens if I go back here to the original way it was written, 4x plus 2y, I claim x equals 2, and I say y equals 4. 4 times 2 is 8, and 8 plus 4 does equal 12. So 2 and 4 is what satisfies both equations through the method of substitution. Now note, to sum up, that we had to have one of the equations solved for a variable. In other words, in one of the equations, either x or y had to be by itself so that we could go to the other equation and substitute it in. So, if you were to encounter something like this, let me show you here in a second. If you were to encounter something like this, right off the bat, you couldn't do any real substitution because we don't have any of the variables by themselves. So if you wanted to use the method of substitution in this case, what you might need to do is get y on this first one by itself. You could do that by subtracting 4x. Y equals 12 minus 4x. Now you have it in a position where you could do some substitution by taking that right there and substituting it in for y. And if you did in this case, you'd have to put the y here. Don't forget the 2. You're only removing the y, and then you'd have to do distribution with the 2 to this expression right here. So that sums up the substitution method for solving systems of equations.